Assalamualaikum to Dr. Hafiza. So we are from Group 4, going to present our group assignment project, DFT calculator, fast Fourier transform. So this is my teammate for our group assignment. The first, our leader, Nur Shafika, and then Ainul Nuraina. Next is Camelia and Hasik. So for the introduction, digital signal processing (DSP) involve processing real-world signal by converting them into numerical sequence, and then using mathematical technique to analyze or enhance them. Signal are represented digitally, making them easier to manipulate using integer, and this representation involves quantizing attributed like time. The discrete Fourier transform, DFT, is a method to convert the signal into their frequency domain representation, uh, uh, decompos- decomposing them into sinusoidal component of different frequency. To speed up this process, the fast Fourier transform (FFT) algorithm efficiently compute the DFT by breaking down data into smaller sets for transformation. Therefore, this project aim to explore and compare the properties and capabilities of this transform, providing insight into their application in signal analysis process.
Okay, for literature review, DFT and FFT. The discrete Fourier transform, DFT, is a way to transform a signal from the time domain to the frequency domain using the sum of a sequence of sine waves. The fast Fourier transform, FFT, is an algorithm that quickly computes the discrete Fourier transform, DFT, and its inverse. So first, the theory behind the FFT algorithm can be tracked back to Carl Friedrich Gauss, who formulated the algorithm way back in early 19th century, although it was not acknowledged at the time. So next, the DFT proved useful only when digital computing entered the scene in the 20th century. In 1965, the FFT algorithm, which was developed by James Cooley and John Tukey. Next, FFT is an efficient algorithm used to compute the DFT and its inverse, which is utilized time for real-time data processing. Then convert data from time domain to the frequency domain, which is important in signal processing and not just limited to image transformation, but is also used in different science and engineering disciplines. The FFT dramatically reduced the number of computation needed for the DFT, making it much faster and more practical large dataset and real-time application.
So for problem statement and objective, in digital signal processing, DSP, the discrete Fourier transform, DFT, play a curious role in converting discrete time signal from their original time domain format into the frequency domain. This transformation is vital for tasks such as analyzing spectra, filtering out noise, and extracting specific feature based on signal frequency. In this project, our focus will be on implementing and understanding the discrete Fourier transform (DFT) and efficiency efficiency of fast Fourier transform (FFT). We aim to develop a calculator that can compute the DFT of a given sequence of number. This total will take an input sequence and transform it into the frequency domains representation using the DFT method. So our approach involves applying the technique learned in class and reviewing lecture notes to design and simulate the system effectively. So lastly, we plan to utilize by using microcontroller to ensure the optimal performance and accuracy in our calculation. So our objective, the first one is able to design and do the simulation of digital signal processing with using microcontroller MATLAB software and Arduino IDE. And then the second one to prove the calculation by using manual calculation FFT and DFT with the simulation. And the third one, to analyze the difference between DFT and FFT technique in digital signal processing.
So now I will be in charge in the methodology part that consists of three parts, which is about the block diagram on problem solving, flowchart, and also the three method approach that I have been using to solve the equation for this assignment project. So now I will be explain about the block diagram on problem solving. So the first step, we want to find the equation for our assignment project. So to do that, we have to determine the topic that related to the question first, and then address the issue
So now we
that
move
has
to the
to be
flowchart
resolved for
explanation.
the
So basically, in the
assignment
flowchart
question.
explanation, it will be
After that,
explaining
we go
about
to
how
the
the
generate
MATLAB
idea
software
step.
will
So
be
the generate
functioning
idea
to get the
step is
expected
all
result
the
for
group
the
members
our question
compulsory
assignment. So
contribute
it will
to
begin by the
the
start button, and
discussion
then
and
we will
brainstorming
create the coding for a
the idea
discrete
for
transform
the
function
project.
DFT
And
calculated by using the MATLAB
by
programmer.
doing the
So in this stage,
researching
we have two
through
conditions,
the online
which are
database,
yes condition and
article or
no condition.
journal to
If we
collect
go to the no
the
condition, the
information
MATLAB
about
will directly jump
how to build the
to get the
DFT
desired signal
calculator.
result and go to the analysis, the finding,
After
and
that,
then
we
do the
go to
discussion and
the
already
stage
run
of
the
evaluation and
simulation.
select the
If
solution.
the second stage,
So
we go
in
to the
this
yes
stage, we have to
stage.
describe the
From
theory
we create the
and the
coding of
concept
the FT calculator by
of
using
the
the MATLAB
DFT,
programmer,
and then we
it will
have to find the
undergo
solution of the
the run
question will be solved
simulation
by
and
three
then get the
techniques,
desired
which
signal
are
result
manual
and
calculation,
then go the same
MATLAB
stage
software, and
of
Arduino
no stage,
IDE.
which it will
After
go
that, we go
analysis the
to the
finding, do the
result and
discussion, and
analysis
already
step,
end the
which
process.
is we have to make
So the
sure the answer
comparison
of
of
many
yes and
calculation
no
correctly answered and
stage,
calculated
no,
and compare it by
it
the
doesn't go to the
using
run
the MATLAB software. And
simulation, but
then we
yes
have the
stage
expected
it will go
result
the
by
run simulation
using the
stage.
MATLAB
So that's all
software can compare
from
with
that
the
part.
Arduino IDE. And then the three expected result must be achieved by these three techniques to ensure that our design process is correctly answered. In this project assignment, we use three method approach to solve the question, which are manual calculation, MATLAB software, and Arduino IDE. So for the first is manual calculation. Manual calculation serve a valuable purpose in in the learning process. Manually working through the DFT formula allow us for understand the step-by-step understanding of the transformation process. The other reason is we want to compare the answer of manual calculation with the answer that we get from the MATLAB software and Arduino IDE, either is correct or not with the manual calculation. For the second method is MATLAB software. So as you know, many engineering students are engineers need to study the MATLAB because it is such an essential program and it's aids in mathematical calculation, design, and analysis. The results are produced with speed, accuracy, and precision. Moreover, toolboxes are specialized solution used in MATLAB because it allows us to learn and apply specialized technology. Lastly is the Arduino IDE. IDE stands for the Arduino Integrated Development Environment. Is a cross-platform program that makes it simple to write the code and upload into an Arduino board. The Arduino IDE uses a condensed form of the C++ programming language and is based on the processing IDE. There is a text editor, a compiler, a serial monitor, and a library manager. So that's all for the three methods that I have been using for this assignment project.
Assalamualaikum and a very good morning. My name is Nushaka binti Rusli and my metric number is TE210032. So I'm going to present about result and also discussion. So for the result of the manual calculation, we get the value of x DFT k is equal to 6, negative 2, negative j2, 2, negative 2 plus j2. So this is the result for the manual calculation. So for result in the MATLAB, there are two, which is in the common window and also from the graph. So in the common window, there are three results, which is the result of DFT, and then the result of real part and imaginary part. So the DFT of xn 1230 is 6 plus 0i, negative 2, negative 2i, 2 plus 0i, and negative 2 plus 2i. So as you can see from here, it divides to two parts, which is real part and imaginary part. So for real part, we get 6, negative 2, 2, negative 2. So for imaginary, we got 0, negative 2, 0, and 2. So this is the result for the graph. So as you can see, the top is the real part and the bottom is the imaginary part. So when for axis x, when x is 0, the value of y is 6. So when x is 1, the value of y is negative 2, and when the x is 2, the value of y is also 2, and then when the x is 3, the value of y is negative 2. So for the imaginary part, when value of x exit is 0, the y also 0, and x is 1, the value of y is negative 2. So when the value of exit x is 2, the value of y is 0. So when the value of x is 3, the value of y is 2. So this is the result for the MATLAB. And the result for Arduino IDE is, we can see that from the serial monitor, the DFT of xn is 1230. So for x0, the value of 6 plus 0j. So for x1, the value of negative 2 plus negative 2j. So for x2, the value is 2 plus negative 0j. So for x3, the value is negative 2 plus 2j. So this is the result for the Arduino IDE. Discussion. So the first thing I'm going to explain is about manual calculation. So the first step we need to do is to identify the number of FFT stage required. So this can be obtained by determining the length of the signal. So in this case, for our length of signal is 4. So we will need to use the formula, which is n is equal to 2 power of m. So we will get m is equal to 2. So the next step is we are going to reordering the input signal in bit reverse order if m is more than 1. So for the bit reversal ordering reorder, that it will indicate on the binary representation of their position. So the next step is the butterfly diagram. Butterfly diagram is a visual representation of the FFT algorithm. So it will show how the computation are organized across the stage. So butterfly can be divided into 4 parts, which is the input, stage number 1, stage number 2, and also output. The next part is we need to calculate the first stage of the butterfly diagram. So by doing that, we need to do the formula. So for the first stage, to get the value of A, the equation is x naught plus with x2. A is equal to 4. So for B, x1 plus with x3. So the value of B is 2. And then for C is we need to 1 times with x naught plus with x2. x2 we need to times with negative 1. And then we will get the value of C is negative 2. Meanwhile for D, we get negative J2. The next part is we need to calculate the second stage. So the second stage we need to do the same method. So we will get the value of 6, -2, J2, 2, -2 plus J2. So that the final answer for this manual calculation. The next part is I'm going to explain about MATLAB. For this part, it shows that the signal need to be defined by assigning the value of xn is equal to 1, 2, 3, and 0 in the code. And then the length of signal should be also identified as indicator, where it in the line number 5. And then an array X is then initialized with 0, and this array X will eventually hold the result of the DFT calculation. So each element in X correspond to a specific frequency component that make up the original signal. So the next part is we need to find out the frequency in the signal. So to look at each possible frequency from 0 to and -1, and then we will calculate how much the frequency is in the signal. So to do that, we need to go through each number in the signal and then multiply it by a special factor and add up this result. So the sum for each frequency is stored in the array X. And in the simple term, the code will figure out different frequency that make up the signal and save this in the value of X. The next part is it will print the whole array of X, which show the DFT result. Then it just print the real part and also imaginary part result separately. So it will make it easier to understand by seeing all the DFT all together. And then for this part, the code will create a graph with two parts and it will display the DFT result. So the top part show the real component of the DFT result against the frequency index k, while the bottom part will show the imaginary component against k. So after that, we can run the program, and this is the result of the program. So as you can see, this is the top part and this is the bottom part. So this is the result from the MATLAB. The next part is I'm going to present about Arduino IDE. So the first part of the coding is we need to including all the necessary tool, which is arduino.h, mat.h for programming and mat function. So it's set n to 4, defining how long the signal xn is, which is 1, 2, 3, and 0. So it will prepare two array which are x real and also x imaginary to store the result of the DFT. So for this part of the coding, it will set up communication and prepare to calculate the DFT for the signal xn 1230. So this result will print in a specific format, which is xk is equal to x real plus x imaginary to the serial monitor. So it will show the frequency component of the signal. So that's all for Arduino IDE. So from all of these three methods, we can observe that all of the three results are same, which is we get the same value for all of the method.
Hello, Assalamualaikum. My name is Abdul Hasib Abdul Rahman and my metric number is AE210026. So I'm going to present about comparison between manual calculation, MATLAB software and Arduino IDE. So the DFT of the signal is XN 1, 2, 3 and 0, which is compute manually using MATLAB, and with Arduino IDE, the comparison shows the advantage and disadvantage of each approach. So the fast Fourier transform FFT technique is used in manual calculation. This method involves rearranging the input signal in bit reverse order, calculating intermediate values through a few stages, utilizing butterfly diagram and carry out complex calculation for sum and difference. So the result is 6 and -2 minus 2j, +2 and -2 plus 2j. Although more theoretical insight can be obtained with this approach, it can be time-consuming and complex. While for the MATLAB, we use the built-in function to simplify the computation, defining the signal, initializing an array for DFT finding, and utilizing loops to compute each frequency component in the process. The results which match the manual calculation are plotted to visually separate the real and imaginary parts. Next is Arduino. So for the Arduino code, we compute the DFT of the signal, which is 1, 2, 3, and 0. So it initialize necessary variable, compute the DFT using nested loop and trigonometric function, and print the real and imaginary parts of the DFT coefficient to the serial monitor for analysis and debugging purpose. So in conclusion, all three methods produce comparable result. Nevertheless, the manual calculation focus on theoretical understanding, while MATLAB is preferred in terms of usability and visual representation, and Arduino IDE is best suited for hardware level implementation. So, in conclusion, manual calculation, MATLABs, and Arduino IDE are essential tools for understanding the fast Fourier transform (FFT) process and signal processing. MATLAB simplifies complex calculation and provide visual insight, while Arduino IDE functions as a DFT calculator by applying a mathematical approach that is appropriate for real-time and embedded application.
So that's all from our presentation for this assignment project. Thank you.